Thank you very much. Good morning. Thanks for making it in here. So normally at any given conference, I'm always reaching back into the crypt and dropping history on everybody, which I kind of like that role. You know, some people find it a little bit annoying, but I like history. And I've kind of come to cherish it as my own, that at any given conference, I'm the one that's going to be talking about history. And all of a sudden, Hillary Mason goes 19th century on my ass. So I was not ready for that at all. I thought that was a terrific talk by Hillary, obviously. So I guess I'm no longer the history guy, because I mean, this is not 19th century. We're going to talk about the 20th century, and in particular about bringing the Unix philosophy to big data. So first of all, people know what Unix is, right? Show of hands, Unix, like that term rings a bell, good. Unix first appeared, actually first started to be written in 1969, so over 40 years ago, well over 40 years ago, and started to appear slowly in the 1970s. And Unix was an incredibly important development, because it was not just a new system, but it actually represented a new way of thinking about systems. And operating systems prior to Unix, operating systems from the 60s, kind of the primordial era of operating systems, were these big control programs. You know, kind of the master control program you see in Tron. That was kind of the model, this big, all-knowing executive. That it was. I love the fact that they called them executives. You know, this is when we're trying to figure out what the metaphor for computation is. It's like, well, maybe it's your boss. It's like, or no. But so we had these all-knowing control programs, and Multics came along, and Multics had some really interesting ideas. And Multics in particular introduced the idea of a shell and had some other very important notions. But it was still this very large sealed monolith. And Multics was then taken away from Bell Labs. The best thing that ever happened in the history of computing is that the GE 645 at Bell Labs was taken away from them, and they had to go invent their own system on a much smaller computer, on the PDP-8. And they really set out to develop a file system. Ken Thompson wanted to develop a file system, and in what might be the first act of test-driven development, he needed to develop some little programs to test the primordial file system. So ls, rm, cat, mv, these are actually tests for the file system. The fact that we can use them on their own is just a kind of an artifact of history. And they had this idea of minimalism, that these things were very small, this kind of small aesthetic. And indeed, as you may know, many of you probably do know, that the term Unix is actually, it's a homophone of Unix, which is to say the castrati, and this was a castrated Multics. As Dennis Ritchie said, we were a bit oppressed by the big system mentality. I mean, it was the 70s, so you know, these guys were hippies. So they had to be oppressed. We were a bit oppressed by the big system mentality, and Ken wanted to do something simple. So that was, and if we can go to the next slide. Sorry, my PDF is not, there we go. That was the Unix as it was first conceived, to kind of test for the file system, and they're building these small little commands, and they can redirect commands and then redirect output and so on. And then there was Doug McIlroy. So I think we think of the fathers of Unix being Ken Thompson and Dennis Ritchie, rightfully so, because they were the one that got the Turing Award for it and so on. But Doug McIlroy may actually be the proper father of Unix, because Doug McIlroy had really the key idea in Unix, and that is the idea of connecting disjoint components, connecting them together. And he had this idea of hoses, garden hoses. And he kept trying to persuade Ken Thompson and Dennis Ritchie to do it. In fact, he tried to persuade them from 1969, but they had no interest in doing it. And McIlroy just would not shut up about this, and he was constantly going at them and badgering them. And he did this over 3 years. You really have to admire McIlroy for being very persistent about this. And finally, what broke through is he came up with a syntax. He came up with a syntax to express this idea of the pipe, of taking the output of one command and making it be the input of another. And finally, Ken Thompson says, I'm going to do it. Now, history doesn't record if it's like, I'm going to do it, like, all right, I'll do it, or it's like, look, I'm going to do it. I need to get the inflection. I don't know if he felt so badgered and nagged. It's hard to know what he actually felt at the time. But he did it in classic 1970s fashion. It only took a day to implement. And the next day, in one of my favorite quotes in the history of Unix, the next morning we had this orgy of one-liners. Man, that's how you know. Talk about the sweet spot of the bat, man. That is an out-of-the-park home run for software systems, is the orgy of one-liners. If you are ever developing anything in your life that results in an orgy of one-liners, you nailed it. And speaking for myself, when I developed dtrace at Sun, I recall our own orgy of one-liners. I actually don't recall it quite so erotically, but the discovery of one-liners was very important. And I certainly, like, you look at awk and these other technologies, and indeed we saw it on stage this morning with the NSQL. One-liners are terrific. They lend themselves very well to orgies, and apparently there was a terrific orgy of one-liners in AT&T Bell Labs. If you've actually seen photos of these people, this visualization becomes very disturbing, actually. These are, at the end of the day, super nerds. But it was actually the pipe that gave us the Unix philosophy. The Unix philosophy, as articulated by Doug McIlroy, is that we should write programs that do one thing and do it well. Write programs to work together. Write programs that handle text streams, because that is a universal interface. This is from the early 70s. And I think this is absolutely true today. I think we should strive for all three of these things in the way we write our software, in the way we think about our systems. And the interesting thing to me is that this did not predate the pipe. They didn't develop the pipe because they had this philosophy. They developed the philosophy because they had invented the pipe. And I believe that this is the single most important revolution in the history of software systems. This idea of building small, well-defined tools. Indeed, I've come to see the history of software as a battle between the forces of good and evil, the forces of simplicity and complexity. And I hope I don't offend too many people in the room, when I think that the manifestation of this is the battle between frameworks and libraries. Libraries put flow of control with the user, and I pick up various components to do something new. Frameworks kind of trap me in someone else's control. The control has been inverted, and they're complicated. J2EE is not the Unix philosophy. I feel I can speak ill of J2EE because I worked for Sun for 14 years, and that's now in a watery grave, so I feel I can speak ill of J2EE. Does not represent the Unix philosophy. But the Unix philosophy, very important revolution. And I think that its moment of triumph, its moment of pubescence, if you will, in 1986, John Bentley posed this challenge that I think has become the epic rap battle of computer science history. And that is to read a file of text, determine the n most frequently used words, and print out a sorted list of those words along with their frequencies. This is like an interview question for an intern today, right? And it is an interview question for an intern because Unix has given us the gift of simplicity that allows us to solve this ad hoc problem dynamically and quickly. Don Knuth, father of computer science, obviously one of the fathers of computer science, terrific computer scientist, took on this challenge. And you should go read this paper, I'm not exaggerating, wrote a 7-page paper describing the bespoke algorithm he developed to solve this problem. And he did it in a new system that he developed called Web. It's this Pascal-like literate programming system. You haven't heard of it for a reason, as they say. And it was, I'm sure, beautiful in its complexity. But ultimately, it was a ridiculously complicated solution to the problem. And then Doug McIlroy, hero of systems, emerges like Indiana Jones and fires his revolver at this complexity. I realize now that I'm getting so old that that's actually becoming a dated reference. I was horrified that Hillary Mason's implication that some people don't know what the A and B drives were. Like, I don't get it. Why is that funny? What the A, like, oh my God, I do get it. I'm old. So anyway, Indiana Jones, you should go see it, and then you can go argue with your older coworkers about whether it's a good movie or not. Which it is, by the way. You're wrong if you don't. Anyway. But the Indiana Jones style slays Don Knuth with this very simple pipeline. Beautiful triumph of the Unix philosophy. But with big data, history seems to be repeating itself. And it seems to be repeating itself almost pitch perfectly. In the original Google MapReduce paper from Jeff Dean in OSD 2004, poses a problem that, boy, does this look a lot like Bentley's problem, the URL access frequency problem. Processes logs of web page accesses and outputs URL, 1, and then a reduce function that adds all these together. the solutions, if you read the paper, it's funny because the paper is aware of Unix, clearly. But the paper desecrates the Unix philosophy. And the solutions that we have today do not adhere at all to the Unix philosophy. And forget not actually using the actual tool set. Philosophically, they are divergent, and they're these ridiculously complicated solutions. And in particular, you look at Appendix A of that OSDO4 paper, it's got a 71-line word count in C++ that has clearly been grossly simplified so they can fit it on the page. You know that sucker's actually like a couple hundred lines. 71-line word count in C++. If I ask you to count the words in a file, you don't think to yourself, okay, I'll need a C++ compiler. It's like, no. You think to yourself, okay, I'll just use like WC, right? WC, word count. A command so old it has 2 characters. It's in the lizard brain of Unix. And you know, when we Unix folks think we need to count the words, let's use WC. But when we count the words in terms of big data, well, no, now you can't use WC. Now you got to take C++ off the shelf. You got to go to Hadoop. You have to do all this complexity. Why? Why can't we take the Unix philosophy to big data? Now, what are the challenges here? First of all, and I love Hillary's definition of big data. My definition of big data, I guess, is the pedestrian one. It's bigger than the machine I can currently work on. So that definition obviously changes with time, but and it's quantities of data that dwarf a single machine. You got to allow for massively parallel execution. You have to allow for multi-tenancy. And to make use of both, not just the Unix philosophy, but by the way, that great tool set, WC and grep and so on, you've got to be able to virtualize the operating system. So let's talk about how we can go do this. Scaling storage, first of all, there are 3 protocols for storing things. You've got block, file, and object. Block, let's say sans. We're not going to talk anymore about that. Far too expensive, very expensive at scale. Can't possibly work for a lot of reasons. NAS, file-based protocols. The file system is actually too permissive an application to be able to build scalable big data systems, I believe, because it implies a level of coherence that's actually very hard to implement. A file system allows you to modify a file in the middle of it, right? If you make available a file system, someone's going to put their database on it. Please don't do that. Do not put a transactional load on what needs to be a big data distributed store. It can't possibly work. Why? Because of cap. Eric Brewer has given us the gift of cap. It's a gift because it tells us we can't actually have it all. Cap being consistency, availability, and partition tolerance. You can only pick 2 of those. Asterisk, you have to pick partition tolerance. It's like, wait a minute. I was psyched. I'm gonna pick C and A. It's like, no. You have to pick P. It's like, oh, damn it. All right, so you have to pick C and P or A and P. And fortunately, object storage, like S3, is just similar enough to a file-based abstraction, but because it doesn't allow for partial writes, we can actually make proper cap trade-offs. So what does an object store look like? Traditionally, for both durability and availability, objects are erasure encoded across nodes. You store an object to S3, and it gets splatted across many different nodes. It gets put into a wood chipper and spread across a bunch of different nodes, so it can survive the failure of any given node and reconstruct the object. Now, a different approach is to, instead of splatting it across nodes, is to actually have a highly reliable local file system and splat that object across spindles. It gives you the same kind of durability and resiliency. It's at the spindle level instead of the compute node. And that's what ZFS does. So I don't know how people have heard of ZFS, a file system we developed at Sun. Thankfully, Sun did everyone the favor of putting all of its source code into lifeboats and sending it out into the world before the vessel actually sank. So we actually have ZFS, we have dtrace, and so on. And ZFS represents one of the 4 foundational technologies in our SmartOS. So, okay, what about virtualizing the operating system? Well, historically, we mentioned that our requirement to be able to use the Unix philosophy is we have to virtualize at the layer of the operating system. Historically, since the 60s, we have virtualized at the layer of hardware. And this is still true today, right? If you go spin up something in Amazon, or if you go spin up a Linux virtual machine or a Windows virtual machine at Joyent, you are going to be given virtual hardware. I will give you a virtual microprocessor, virtual x86, virtual DRAM, virtual NIC. You are going to put your own operating system kernel on top of that. You don't really think of it that way because all that stuff kind of happens for you automatically and you pop into a shell. But what has actually happened is this horrific slaying of kittens that has allowed us to have this virtual abstraction. And it's a slaying of kittens. It's a kitten slaughter because, and this may be an inappropriate metaphor, it's a kitten slaughter because the operating system doesn't really get along well with others. Trust me, I'm an OS kernel guy. I don't get along well with other software engineers. It's like, no, I will control the hardware. And so the operating system, the virtual operating system, believes that it controls its virtual hardware. And you start having a lot of these sitting side by side, and the box is in a lot of pain. That does not lend itself well to multi-tenancy. They're heavyweight. They've got a lot of issues when we want to go virtualize the operating system. There's another approach. We can instead virtualize one layer above the hardware. Instead of virtualizing the hardware, let's virtualize at the OS. One OS kernel, and I will punch out a container for you that is entirely secure. You can't get into anyone else's container, but your app is actually sitting there on the metal, on the hardware. You don't have the performance effects of having to virtualize hardware, and these things are very lightweight. They spin up, they spin down, and this was pioneered by BSD's jails. Zones, first in Solaris and now in Illuma systems like SmartOS, have taken it to the logical extreme. All right, so we've got ZFS. We've got the kind of the raw ingredients here. Can we combine ZFS and zones and develop an object store that has compute as a first-class citizen? Thanks to ZFS rollback, we can allow for zones to be completely trashed. So we've got an object store where you're going to store your objects. When you want to execute compute, I will drop your compute right in the zone here. You can do whatever you want in this little virtual environment, because when you're done, I'm just going to roll you back and clean that for the next person. You've got some job scheduling that we need to go build, and what this allows you to do is actually use the proper Unix toolset. You want to do a word count across 1 million documents, use WC. It's what God, or at least McIlroy, intended. McIlroy will be pleased. So this may seem obvious. It really wasn't obvious. And I've kind of told this story like, oh, we were going to bring Unix to big data. It's actually not the story at all. It's kind of a nice little rewrite of the origin story. The actual origin story is, we want to go build an object store. Can we go do something interesting? And I was fixated on the ZFS aspects of this. Like, what can we go do with ZFS? And I'd just totally forgotten about OS-based virtualization and zones, which of course we built our entire business on, so it's kind of ridiculous that I forgot about it. And we had an engineer who come from Amazon, Mark Cabbage, and Mark was the one who had the insight of, wow, can we combine these things? And I just blew my mind. Of course, oh my God, genius. And when I went to think about it later, I was like, you know what's strange is I remember my mind being so blown by that, but I don't remember Mark actually telling me about it. I know Mark told me about it, but I don't remember the conversation. And normally, when you have that moment, like we heard on stage this morning, you have that moment, you just lock everything in. I know exactly where I was. And I couldn't remember where I was. And so I went back over my IM logs. I'm like, where the hell was I? Thinking like, maybe let me find the first conversation that we talked about Manta. I'm like, oh my God, this is why I can't remember where I was. Mark told me over IM. So this is literally a transcript of my mind detonating. As it turns out, when my mind detonates, it's laden with curse words. So Mark says, hey, we could escalate MapReduce to a first-class citizen by way of routing your JavaScript code to some node thing, running on a separate zone at the same place as your data. Not sure this will be viable or not. And of course, over here, I'm like, and fuck, that's a good idea. You fucker, that's a really good idea. That's why I was asking about zones and ZFS and ACL's cross zone. And then, of course, I'd just begin swearing. Fuck, 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 fuck. And like, why didn't I think of that? That was right in front of me. That was right in front of me. But sometimes it's like the pipe. The pipe feels so obvious. The power of the pipe is so obvious. And yet, not only was it, I mean, at least, give me this. Mark didn't have to beat me within an inch of my life for 3 years, which is what Doug McIlroy had to do to Ken Thompson and Dennis Ritchie to get pipes into Unix. So at least he didn't have to hit me with a baseball bat. At least I got it. You know, sometimes these simple, powerful ideas, they're not obvious. But boy, as soon as he articulated that, it's like, oh my God, that is a terrific idea. So what we've built is a system called Manta that realizes this dream. So we built a distributed system, sophisticated being a euphemism for ridiculously complicated and hard to get right. On top of ZFS and zones, and this allows you to have in situ compute. And what it allows you to do is, again, store your objects. And when you want to do something to them, instead of backhauling them to transient compute, instead of backhauling your objects from an S3 to an EC2, or backhauling them into some infrastructure as a service compute, you actually operate on them in situ. You want to grep your log files for a particular UUID, you just execute grep. And that grep will run in parallel wherever your objects are. So you can go through a redonkulous amount of data in a very short period of time because you're not moving it. We've fundamentally changed the physics of big data. And by the way, like just the raw tool set we have in Unix was built to do this. Grep is really good at this. Oh, how many people program in awk? Give me some love. Oh, sorry. So those of you who haven't, you've got to go check. So awk built in 1977, and awk is, if Unix is the Old Testament, awk is the beginning of the New Testament. So awk, an incredibly important language that has inspired Perl and Python and many other higher level languages beyond it. But awk is so beautifully simple. It's so tight and so fast, and it's a very tight little language that allows you to pattern match in text files and take action on them. And it runs like a bandit, and so much that we do today with these ridiculously complicated Baroque MapReduce frameworks can be implemented in several lines of awk. It is an orgy of one-liners waiting to happen. Like, awk is always down for an orgy. I'm not sure if that's the way Peter Weinberger thinks of it, but that's the way I think of it. So we can do all of these things using this terrific tool set. And so actually, if we go to Bentley's challenge, this is the McIlroy solution to Bentley's challenge cast in terms of Manta. And this is literally like, we can go cut and paste this. In fact, I'd like to go do that. So I'm going to go, we're going to go cut and paste this line. And so what I'm going to do is execute an mfind over my directory, and what I've stored here is a bunch of objects that are the V7 man pages. I think as long as we're talking history, and that said $1Q. I'm not sure why McIlroy he has a solution in terms of set instead of head. I'm not sure why, but I'm going to change that to a 100 so we get the top 100 things. And what we're going to see is that it's going to, assuming the Wi-Fi works, I should have checked that before, that we've added a bunch of inputs to this job. And what I'm going to go do. We can go check on that. We'll do a little mjob get of this thing. Oh, it already finished. That's disappointing. All right, well, before I could even check its status, it finished. And so over here, we can see that we had 308 tasks, and now, of course, 308 are done. And we can see exactly how long it took. And over here is the output. So what has happened here? What has happened is that we've got 307 different objects across the joint Manta cloud on many, many, many different machines. In parallel, we kicked off this little pipeline, McIlroy's beautiful pipeline, and then we threw in some Aho, Weinberger, and Kernighan in there with some awk. Beautiful, beautiful awk. Orgy-tastic. We kicked that off everywhere, and I should say that this is what we kicked off everywhere, this little map phase, the TR, the sort, the unique. Then the -R denotes a reduce. This is our reducer. Our reducer is simply taking all these different 307 outputs and just collating them effectively and giving you the output. And you can see how quickly it ran. And by the way, most of the time that it was running was all of the bureaucracy required to actually get these jobs launched. If these files had been, instead of just being several K, were several hundreds of megabytes, the runtime would not have been materially different. Because the object, again, is not moving. How long does it take to run a TR and a sort and a unique on an object that is a couple hundred megabytes? Like, not long, right? Because you're just reducing the data so much. So actually, let me just show you this as well, just to give you a flavor for it. So we'll just show you this mfind again. And as this kind of implies, we actually have a true file system structure. It's not an actual file system, but we actually have a file system like hierarchical structure. If you've used S3, other object stores, you know they violate one of the most important gentleman's agreements we have in computing, and that is that the / always denotes hierarchy. If you are going to name anything and the / is going to not denote hierarchy, do the world a favor and reject the /. Because it's not what the person who created that object believes that it is. For us, and that, by the way, is a multixism. That's where Multics initiated, developed the /, and then, of course, DOS had to destroy it. But we have actually a true file system-like structure, and which allows me to list directories and so on. And those directories are, of course, synthetic. It is a distributed system. And if I want, let's actually backgammon. If I want to actually get this object, I can just mget it, and this is going to be, okay, this program does what you expect. It will, I love this. This is what I love about Unix. It will ask whether you need instructions. End of man page. Documentation over. Some things never change. So what I'm actually going to do now is something that is a little bit ridiculous for such a teensy tiny object. But now I'm actually going to log in to the object, because another thing that we developed because we thought it would be useful would allow you to run a job that is interactive. So I'm now running a Manta job, and I have now, if you will, logged into this object. And if I look at my environment variables, I see that I have this Manta input file that is this object. Not interesting for an object that is, I mean, how just obscenely tiny is this thing? For an object that is 182 bytes, not really interesting. But for an object that is 182 gigs, much more interesting. Because that object, you can't actually meaningfully kick around. 182 gigabytes takes a long time to move around, even if you're over 10 gig. So the ability to actually log into the object, and then you can actually, and I in fact did this when I was getting McIlroy's solution to work, you can actually develop your little pipeline here and get it to work on that one object, and then take a step back and apply it to 10 objects, and then 100 and 1,000 and 1,000,000. That is the Unix philosophy. Start small, start simple, get it working, build it bigger. And that is what has enabled us to build really the most important systems that we've been able to build. So, and just to, and I know I'm shy on time here, but so in terms of cap trade-offs, there are many more details on Dave Pacheco's blog on this. Eric Brewer gave us a totally unsolicited celebrity endorsement when he said it was a good example of the correct way to apply the cap theorem. I'm pretty sure I teared up when I saw that. I'm pretty sure Dave, who actually wrote this analysis, had a seizure when he saw that. I think we all view Brewer as somewhat of a celebrity. And you know, in terms of the way we've implemented it, we've got full support for CORS headers, all the kinds of things you would expect. We've got a terrific, or really interesting, I think, SSH-based HTTP auth mechanism, and more details on that. You can get all, and I'll have a last slide where you can get a bunch of additional information. In terms of the future of big data, I mean, that's what this conference is about. I love the tone of this conference, the FutureStack. I can tell you this for absolutely certain. The future of big data is compute data convergence. No question. It is much easier, much easier to bring our compute to data than it is to bring our data to compute. No one talks about like big programs or big text. It's not a big text movement, it's a big data movement. You want to bring your program text to your data, not the other way around. Bring Muhammad to the mountain, as my mom used to say. She grew up in Saudi Arabia. Marketing folks said we weren't going to use that for marketing, but I think we should. I think it's a great expression. And Unix, we believe, is the natural way of expressing this computation. Unix is a great fit for bringing the compute to data, and OS virtualization is just the right way to virtualize. We think ZFS is the only sane way to do it, but you know, go ahead and knock yourself out on something else. I don't think Manta is going to be the only system that does this, because this is such an important and powerful idea that others will do this, and which is great. I think it'll be a revolution for humanity. But Manta is, I think, actually the first system that allows you to take the general purpose Unix primitives and apply them to data in the large. And it's changing the way we develop software. So we are developing our own systems based on Manta. In particular, I'm a disaster porn addict, sadly. I'm like the Charlie Sheen of disaster porn, though, because I have no actual remorse about it. I just, look, a plane crashes, I get titillated. I'm really sorry. It's true. Especially when, like the one at SFO, like no fatalities. Ooh, that's the best one. Except for the girl got run over by the fire truck. But you know, that's kind of interesting in its own right. But I love disaster porn, and in software engineering, disaster porn is core and crash dump analysis. Core and crash dumps are really big. You don't want to move them around. So what do? We've got a system called Thoth that is a Manta-based system for which we do all of our core and crash dump analysis. So anytime an application dumps core in the joint cloud, it goes into Manta, where we can then either debug it or just fetishize about it if you're into like an orgy of disasters like I am. In terms of more information, you can just Google Manta, of course. There's a Node.js module, Node Manta, that gives you the CLI. The documentation, we believe, is actually pretty thorough. You can hit #Manta on Freenode. The Manta engineers are hanging out there. And then along with, follow Mark Cabbage and Dave Pacheco, Yunong Zhao on Twitter, the core team behind Manta. At least those are the core team that are actually on Twitter. There are, of course, some other engineers that are such introverts that are not on Twitter, which is great. And then join. And with Manta, we have been able to deliver on the dream. With Manta, we actually have big data one-liners. So with that, let the orgy begin. And thank you very much. And I don't know. Oh, am I allowed to exhale? You're allowed to exhale too. Actually, sorry, I know I give people kind of a fight or flight reaction often when I present. Yes, absolutely. Yeah, it's right. Sorry. Yes, look, can we get the last slide back? Just so folks can take a quick photo of that. And I don't know if I've got any time for questions or not. But if you do have any questions, definitely come up and feel free to see me, and would love to talk with you about your thoughts on big data. Yeah, so the slide this is the modern day, and actually because this is in my public, when you sign up for Manta, you can just cut and paste and run that, and you can just run that yourself. You yourself can do a word count over things in the 7th edition man pages, and then go appreciate the glory of the backgammon man page. Yes. Yes. Yeah, that's a great question. We're going to open source Manta. So first of all, Manta is built in Node.js. It's built on a lot of components that we have open source. I'll get to your question in a second. So many of the components are actually open sourced. We believe fervently in open source. We're the company behind Node.js. We are a fervent steward of Node.js. We believe in the community. So for virtually all the software we develop, we have an open source trajectory for it, which is a way of saying not yet, but definitely stay tuned. And a lot of the things we've used to build Manta, you can use yourself to build your own apps, be it LDAP.js or Node Restify, Node Bunyan, and so on. Any other questions? Super. Thank you so much.